You know where to find me on Twitter. I'm also there on GitHub, Stack Overflow, and all the other places where coders can share code and exchange advice or search for technical information. Let's dive a bit deeper into one of the aspects I talked about this morning. It's about the automation of your continuous integration, continuous deployment pipeline, how you can minimize the time between the moment you are writing code and the moment where that code is in front of your customer. Because remember, code is an asset, code is a liability. So any type of code that you keep in your Git and not expose that code into production, it's an investment that you made. You work on that code. You work to develop the code, to test the code, and that code is not bringing you any value. The only value where code can have value, it's when it's in production in front of your customer. So you should really try to minimize the time it takes to bring code from Git, from your repository, to production. And you can do that by automating your build, automating your tests, automating your deployment pipelines, and even automating the deployment of the deployment pipelines themselves. I'm going to try that, to show that in a demo. So I will not talk about that again because you were there this morning most of the time. So you saw the monolithic application for Amazon in 2001, how we restructured the company into small teams, 2 pizza teams in charge of their own services and gain better agility as a result of that. One of the problems we had when we did that is that we have many developers contributing to many services. And then the deployment pipeline was still a unique deployment pipeline for all the developers. Even if it was not a monolith anymore, the way to bring code into production was one single central system. And it doesn't scale. It could not actually be as agile as the team were. So what we did very quickly, we had to define a way, an internal system, to bring agility to the development pipeline by itself. And that's why we decided to give a deployment pipeline to every single developer. When the developer joined the team, he received its own CI/CD pipeline and its own environment where he can test his code or her code inside the cloud. But to build that, we need a standard way to build a deployment pipeline with some safeguards, with the best practice, with the security inside that. So we need a tool to quickly create that. We cannot just go into a console and do click and click and click and click because this is not repeatable. So we need a repeatable way, not only to bring code to production, but also to bring deployment pipelines to the developer. And that's why we start to develop internal systems to build and to orchestrate the builds and the tests and the deployments to production based on API. And these systems are now available for you as customer. You can reuse these public version of these internal tools that we built more than 10 years ago. So the idea is really to experiment more often, because if you experiment more often, if you lower the cost of entry to try a new idea, you mathematically increase the level of innovation within your team. If you lower the barrier for failure, if you lower the barrier for entry to test a new idea, you can have more innovation. You can also listen better to your customer, and everything we do at Amazon is driven by customer feedback, so that's how we close the wheel. Experiment, listen for customer feedback, iterate based on customer feedback, and improve the quality of the different services. 3 different changes that was required to bring CI/CD to the team. Of course, change the architecture and go from monolith to microservice, and that's why you are here, and we are going to talk about that during 3 days. We talked about that already this morning. But also go to serverless, and I briefly mentioned that this morning. Do not ask your team to manage infrastructure. If there is no infrastructure, you are more agile because you are not spending your time on doing undifferentiated heavy lifting, low level, what I call plumbery, the things that everybody has to do: spin up a server, install an operating system, patch the operating system, install monitoring agent. Serverless doesn't mean there is no server, but serverless means someone else will manage the server for you. You pay only for what you use. If you are not using the service, you are not paying for it, and it will scale automatically, so you don't have to think about high availability and scalability because it's designed inside, it should be designed inside inside the service. And of course, change the way you do software delivery, and that's what I'm going to talk about right now. So I guess you saw that type of graph already. When talking about CI/CDs, you have multiple steps, multiple phases with your source code, the build phase, the test phase, or many tests, different tests, and finally production. So continuous integration, it's everything about the build. The idea is at any moment in time, you have a fully functional build, something that works. It means, if possible, every time you commit source code in your repository, you trigger a build and you have a clear dashboard, clear metrics about is the build going through or is there any error. It should be the first priority of a team to fix the build if the build is broken. This is how it works at Amazon. So if someone breaks the build, all other engineering activities are stopped until we fix the build. At any moment of time, we need to have the trunk, the main line, entirely buildable, not billable, but buildable. The next step, and fewer companies are going into there, it's continuous deployments. Every time you make a change in your source code, you want to bring that change in front of your customer because that's the only place where you can actually get feedback about the change. And this is the only place where code is bringing value, maybe bringing money to the company. It's when the code is deployed into production. So I'm going to talk about these three different aspects and maybe add the first one, which is infrastructure as code, because it's the enabler of the two other. So IAC, infrastructure as code, not to be misinterpreted as IAC, infrastructure as click. Infrastructure as code is really to write code to define your infrastructure. So you want to make your infrastructure repeatable. I used to work for banks and large public organizations where some things works in the test environment, but when you move to production, it doesn't work anymore. Does that sound familiar? It works on my laptop, it works on the dev environment. Why? Because someday someone SSH into a server, install a dependencies, a library, and that environment, no, it's not exactly the same as the one you're using for testing or for building. I see the smiles on your face. It's very familiar, apparently. So you don't want that to happen. You don't want to have what we call a snowflake server. You know what is a snowflake server? A snowflake, flocon de neige, it's all snowflakes look alike from distance. But when you get closer, you notice they are all different. And you don't want that in your infrastructure. Your production, dev, and test infrastructure should be all identical, down to the comma, down to the little details. You don't want snowflake server. And one way to get that is to automate your infrastructure. So instead of creating your infrastructure by hand and managing it by hand and trying to remember, oh, I apply a patch there, so I need to apply the same patch over there. No, it's to build an infrastructure with code. And public clouds allows you to do that. That's a big difference with on-premises. With public clouds, you have APIs, so you can define your infrastructure in a text file. You can have your data center in Git. Think about the things that you can do with that. It means you can apply formal verification, programmatic verification. You can spin up an environment just to create a test. I execute the script, it creates an environment, I execute my test, and then I delete the environment and I stop paying for that. And if I need to create a new environment tomorrow, I will re-execute the same script, and I'm 100% sure that the environment will be the same as the one I used to test today. We have that concept, and many customers have that concept of immutable environment. You do not change an environment. You never SSH into a machine to make a change. If you need to make a change, you change your script, and you create a new environment. Of course, in such a way to not interrupt the service. You don't want to drop the availability of the service for your customer, but you do not change a running environment. So there are different ways to do infrastructure as code. You can write a script, like a bash, with commands. I'm creating the network, I create a load balancer, I create the instance, I create this and that. Shell script is great. It's great to experiment, but it has a couple of drawbacks. One of them is that you cannot delete the environment. You need to write another script to delete the environment because the order does matter. You cannot update the environment. What if you need a different version of, I don't know, Linux or Windows? You cannot just change a parameter and re-execute the script because it will recreate another environment. What if you can just make the change to that environment based on your script? So that's the imperative way. I tell you what to do. Cloud provider comes with a different way. It's the declarative way. You declare what you want. I create a list of the things I want, and you give that to a service, and the service will quote execute the list, and will create the infrastructure for you. So if you're running AWS, maybe you heard about something called CloudFormation. CloudFormation is a service allowing to do that. You give a YAML file that describes your environment, and you give the YAML file to CloudFormation, and CloudFormation will, quote, execute the YAML file, create the infrastructure for you. If you change the YAML, you give it back to CloudFormation, it will apply the difference, the delta from what is running and your file. YAML is good, but it's quite low level. It requires a lot of lines of code because you need to create a network, you need to create a subnet in the network, you need to create a gateway, attach the gateway, change the routing table, and then create a server, attach the server to the network. It's really, I like to say, it's the assembly language of cloud. It's very verbose. It's really down to the API, very low level. So at AWS, we came with two different types of libraries. One is really oriented towards serverless. It's called SAM, Serverless Application Model, where you describe your serverless application. For example, here in 20 lines of code, you say, hey, I want to create a cloud function, a Lambda function. This is my runtime, Node.js. The entry point in my code is index.get. The code is at that place. I want to create a table for a DynamoDB, so a NoSQL table, and expose that serverless function with a REST API on /resource/resource ID with HTTP GET. So 20 lines of code, you give that to the SAML CLI, and it creates all the infrastructure to have that in the cloud. So the Lambda function, the table, and the API gateway automatically. So for serverless, super useful and super concise SAM. But what if you want to create more traditional infrastructure, like virtual machines, load balancer, different types of service? We introduced last year the CDK. The CDK is a Cloud Development Kit. And the idea with the CDK is to allow you to write code for AWS in your preferred programming language. So we do support TypeScript, we do support Java, we do support Python. I think we do support Go as well. It's a command line tool, CDK, where you can scaffold your project, and then it's a library of different constructs that you can use. And CDK, the only thing it does is generates a CloudFormation template. So it allows you to use your favorite programming language to generate infrastructure. And the good things about the programming language versus YAML is that you can have condition and you can have loops. So if you need to create 10 server, you can write for I equals 0 until I equal 9, or 1 to 10, it depends on how you prefer to count, and create 10 server with just one loop instead of duplicating, copy-pasting code inside your IDE. And that can be part of your pipelines. Of course, you can create infrastructure as part of the deployment to create your test environment, execute your test, and then tear down the infrastructure. Under the cover, it generates CloudFormation. So we are not reinventing the wheel. It's just an easier way for us, developers, to express the infrastructure that we want. And it just generates CloudFormation. This is an example. That's basically the example I'm going to use in the demo to create a cluster to run containers with Kubernetes. Without server, that's a service that we call Fargate. So Fargate, it's a managed Kubernetes without virtual machines. We do generate and manage the virtual machines for you. You create a network, one line of code. You create your cluster, one line of code, and then 4 lines to create a load balance Fargate service. Means, hey, the line of code says, hey, take that Docker image from Docker Hub and publish that as a service on Fargate with a load balancer in front of it. So it takes like 20 lines of code, 22 lines of code to generate more than 400 lines of CloudFormation and to create a fully available, redundant, multi-data centers or multi-availability zone load balancer service with Docker and Kubernetes. Same if you want to create Lambda function, a few lines of code, the position, where is your code, like lambda handler.python, how to trigger the Lambda function with the last part, the rules. This one will trigger like on the cron at midnight, and 6 if I can read the cron syntax correctly from Monday to Friday. Oops. So that's infrastructure as code. And that's a very important way to manage your infrastructure at scale in the cloud. So what about continuous integration? Managing your source code and managing the build. Of course, you can create your own virtual machines in the cloud and install your favorite build server, and I'm pretty sure you have your favorite build server already, but you are responsible to manage that. I mean, you are responsible to keep the thing up and running. If you have hundreds of developers, you need to scale the thing. You need to patch the operating system, you need to patch the build server, and so on. And that's probably something that has no added value for your business. So what we propose instead is a service fully managed in the cloud called code build without server. You just give us a file, a build file, like a script that will describe the command that this thing needs to do to build your application, and it will build your application for you. So building your application can be anything, compiling, running tests, you name it, it's your script. It runs on Windows, it runs on Linux. Internally, we are using Docker containers, so every time we start a build, we start from a fresh environment. There is no artifact left from the previous build. That's also important. And you have no server to manage. So if you have 1,000 builds per day or 1 build per week, for you it's roughly the same. No, it's not the same. The price will not be the same, but the infrastructure and the effort for you to manage will be exactly the same. And you pay by the minute of build running of the compute resource that you're using for the build. Having a build is good. You go to S3, for example, to distribute the build artifact, or maybe to Docker Hub to store your Docker image as a result of the build. Then you need to deploy that, and this is where continuous deployment happens. So the idea of continuous deployment is to deploy frequently, and if possible, to deploy automatically to production. At Amazon, I only have data from 5 years ago, so sorry for that, apologize for that. I don't have recent data, but 5 years ago, we were deploying twice per second. On average, on Amazon as a company, 2 deployments per second. And a deployment is not a big thing. It's not a new version of a service. It might be a little change in the console or something very, very minor. I used to work as a consultant for a large bank in Luxembourg. These guys were also deploying twice per year. Twice per year, everybody was on call, everybody was working during the weekend. That was the big stuff. And if I, as a developer, I missed the deployment, target the deployment window, my code will be there in production in 6 months for the next deployment period. And of course, it was a big bank with tons of change and tons of things that might fail and tons of things that failed, actually, because when you deploy a lot of code, you have many occasions to miss something and to fail something. If you make a lot of small deployment, it's much easier to revert back and to know exactly what is the commit that break the system. So a good continuous deployment environment has also a mechanism to roll back. It's super important to have good monitoring, to monitor not only technical metric, but also business metric, like I explained this morning. At Netflix, they are monitoring the number of play per second. So if the number of play per second drops, they know that something is wrong in their deployment and they need to reverse back. Same at Amazon. We monitor the number of purchases per minute or the purchase per hour. And we know that if that metric goes down, it's because one of our deployment breaks something. The first thing we do is to roll back. And it's not manual, it's automatic. If there is an alarm, the first operation is to roll back, go back to a stable system so that customer experience is not impacted. That's the most important, to preserve the customer experience. And only then we try to analyze, okay, what was broken, let's fix that, and let's redeploy. Continuously, automatically deploy for testing. continuously, automatically deploy to production in a safe way, in a controlled way. The goal is not to break your production and to not break the customer experience. But the idea is really to reduce the time between the time it takes to make a change and have the change in front of your customer. So there are many ways to do that, but in the same way we have code build, we have also code deploy that allows to deploy anything to anything. So it can deploy on AWS, of course. It can deploy to serverless. It can deploy to Docker. It can also deploy to on-premises. If you install a small agent on your machine on-premises, CodeDeploy can coordinate the deployment between your on-prem infrastructure, the cloud infrastructure, your serverless infrastructure. All it takes to CodeDeploy is to take a small YAML file that describes what to deploy and how to deploy. For some service, like for Lambda, for example, we have different types of deployment strategy. For example, we are using canary deployment a lot, or linear deployment. Canary comes with from the bird name, the little yellow bird. That's because a couple of 100 years ago, when miners were going down in the mines, you know that one of the dangers for miners was to be affected by gas that was producing by the mine. And so they took the habit to take a small bird with them in a cage. And if something happened to the bird, it means that the air was not breathable anymore. It was time for human to go out. So it's sad for the bird, but it helps to save a lot of human lives. And the canary deployment is exactly the same idea. You deploy the new version of your software, and then you send portion of the traffic to that new version of the software, like 10%. And if everything goes well, you increase 20%, 30%. And if everything goes well, at the end, you send 100% of the traffic to the canary version, and you dispose the old version. But if anything goes bad on that 10%, then you roll back the deployment and you go back to the old version. So you can do that automatically with Lambda if you have a Lambda function with a V1 deployed and you deploy it with a CodeDeploy. CodeDeploy will create a second version of your Lambda function and will send, let's say, 10% of the traffic to the second Lambda version. Then it's up to you to have proper monitoring metrics to observe the behavior of that code. If there is an alarm at any point, the traffic will go back 100% to the first version. Otherwise, after a while, 100% of the traffic will go on the second version and you can just dispose the first version. That's canary deployment applied to serverless function. We can do that on Docker container as well. CodeDeploy can deploy a new version of your container and then do either canary deployment, either a blue-green deployment. So blue-green is a bit different from canary. The idea with blue-green is that you have the green version in production. And let's say the blue version in production, because I have an example there. You have the blue version in production, and you deploy the new version, your V2, and that's the green version. And then you tell your load balancer to send part of the traffic to the green version, the V2. And it's the same. You monitor the behavior of your V2. So you have a part of the traffic, like 20% of the traffic on the green version, 80% of the traffic on the blue version. And you monitor, you observe what's happening. If there is no customer call, if all the metrics looks okay, you can gradually increase the traffic until 100% goes to the V2, and at that time you can delete the infrastructure for V1 because remember you have script to automatically delete infrastructure, so you can delete that cluster of your V1 infrastructure. Of course, you have to take care of draining the blue task so that there is no more active connection to the blue version. So that's continuous deployment with CodeDeploy. And to integrate all that, you need some kind of orchestrator, like le chef d'orchestre, the guy that will coordinate all these different tasks. So you need a workflow, and I will show you that in a demo, if the demo gods are with us. I need network for that. Everything is in the cloud. Nothing is on my laptop. So let's see what we have here. I created a very simple Docker application, which is deployed on an Amazon service called ECS. So ECS, oh, you don't see anything. Let me know if you don't see anything there. ECS, it's a service that allows to run a Docker container and to orchestrate Docker container in the cloud. It's not Kubernetes. We have also a service if you love Kubernetes. But for most cases, customers are telling us that Kubernetes is not necessary. It's too complex. And most of the time, you can do you can orchestrate your Docker container with something simpler like ECS. So the idea behind ECS is that you define your service, and a service is something like this. You have a fancy name that because it has been generated by a script, and you tell how many tasks or how many container instances you want up and running. This one is running on Fargate. So Fargate is an environment where you do not need to manage the virtual machine. If I go to my EC2 console, I will not see any virtual machines running on my account. Of course, there are virtual machines underneath. There is no magic. We cannot run Docker without virtual machines. But we do manage these virtual machines for you, so you do not need to manage that. So inside the service, you define the task. The task is roughly the Docker container, the instance that you want to execute. And a task is defined by a task definition. And the task definition will probably look very familiar. It's a bit like a pod file for Kubernetes. It's a JSON file that defines how to run that container in the cloud. So what are the environment variables? What is the log driver? What is the port mapping? All things that should be quite familiar to you if you are running Docker. How many CPU, what memory do we want, and so on, and so on, and so on. So this can be generated automatically. Of course, I didn't type all that myself. So you define your task definition that says what to run, and the cluster will run this task for you. If you are running that on real EC2 instance, you will see your EC2 instance here. Here, I don't have any EC2 instance. They are managed for me automatically. And the service is associated with a load balancer. So if I go to the load balancer console, I can see that I have a load balancer here. Oops. If I click on load balancer, I have a load balancer here, and I have the DNS name of that load balancer that has been generated automatically. And of course, you can use whatever name you want associated to your domain name and any type of DNS. So I have that load balancer that sends traffic to my two containers, container 1 and container 2, that are there. Let's see if it works. I'm switching to Safari here for a reason that I will explain a bit later. And it's a very simple static HTML application. I was very lazy when creating that demo. It's just one of the example from Bootstrap, not even customized. And voila. So that's my setup. I also created, with the CDK, a pipeline. So a pipeline, it's an orchestrator. It's a workflow that defines the different actions to take when something happens on your source code. So it's a very simple pipeline with 3 steps here. The first is connected to a GitHub account. And I can go to the GitHub account. The source code of the application is here. I have my Nginx container that contains my Docker file, my task definition, and the HTML application that you just saw. So that's my source. The next step is to build the Docker image. And the last step is to deploy to my cluster using some kind of replacement container and draining connection and to not interrupt the server. So let's see all that in action. I will first make a change in the source code. I will push that change to GitHub. The change will be picked up by pipeline that will trigger the pipeline. All the 3 steps will deploy, and I will try to explain what's happening while it's happening. So the build and the deploy. So let's start with the easy thing. It's probably a bit too small for you to read there, but that's I can make it bigger. It's just the HTML of the application that you saw, so nothing super exciting there. So let's make a change that will be quite visual. Instead of having the gray color in the background, I will put a more warm color. I will use the Amazon orange, for example. Sorry if you don't like orange, but up FF9900 replace, oops, I have some change there. And let's commit. So I'm using the graphical user interface. I guess you know the graphical user interface of code commit, but this is the equivalent of git add, git commit, color change. That's my git commit. And now let's make a git push. The git push is real because if I reload here, we see that it has been changed now. And let's go back to my pipeline. And okay, the first step is already done. Get source, of course, it's really quick. It's just downloading the source. And now it's building the image. So what it is building, it's using code build, and you can monitor the progress of code build. So code build is just using a build file that you need to provide, and a build file gives the build instruction to the system. So here I have my build file. It's super basic. It's a Docker build, a Docker tag, and after that, just pushing the image to a repository. And I'm using the AWS repository, but I can use Docker Hub as well for this demo. So I can follow up the progress of the build in the build console. You can see all the outputs of the Docker build, downloading the layer, and finishing with upload artifact succeed. That's the best part of the log. It says that, hey, the build has been succeeded. There is no error. Okay, it's a very easy build as well. So the next step, if I'm going back to the pipeline, you see that it just changed from blue to green, and now it's the deploy to ECS, which is there. So deploy to ECS, you can see it's in progress. So if I'm coming back here, what it's going to do, it's going to create 2 new tasks. You see that the tasks are pending, and register these tasks to the load balancer. And then it will drain the load balancer, so wait to have no more connection to the old version. So if I start to reload this, I should eventually see sometimes it's hit on a container that has the new version of the code, and sometimes it's hit on the container that has the old version of the code. So it's either gray, either orange. And after a while, there will be no more connection to the gray container. So ECS will terminate this task, and I will receive only oranges or background. Maybe I should stop refreshing because I'm generating traffic on the old container here. But you see that, yeah, there are 3 right now. And obviously, one of them is still the old version. And the 2 are from the new version. So you can see the version has changed here. I have 1 with version 10 of the task definition and 2 with version 11 of the task definition. And if I refresh now, I just have the old one, so the new one, sorry. So if I reload now, I will just get the oranges. And of course, here I created a very, very simple pipeline. So, oops, that's something else. So it's a pipeline which is just building and deploying, but you can imagine a much more complex pipeline with different testing phases to implement different tests. You can imagine to create an environment, run the tests, delete the environment just after that. You can imagine to have human approval if you don't want to deploy automatically. For example, if you want a human to review the things, you can have a human trigger to say, okay, now let's move to the next step, and you can have multiple branches and create extremely complex pipeline like that. The good part of all that, it's serverless. I'm not running any EC2 instance for my production, the Docker cluster itself. I'm not running any virtual machines for my build environment. I'm not running any virtual machines for my pipeline itself. Even my source code repository, in that case, it's GitHub. I'm not running any virtual machine or storage. I don't need to backup, for example. Did you back up GitHub sometimes? No, I don't. So it's all serverless. And serverless means you have less things to manage, but less things to pay as well. Code build, you pay by the minute, and code pipeline, you pay by the execution. And there is a free tier, so if you want to experiment with that, or if you are the only developer working on that, you do not need to pay anything on code build or code pipeline. Let's recap a couple of best practices I would like to share with you. Manage your infrastructure as code. and not infrastructure as click. So IAC with C being code and not click. Do not click in the console. Clicking in the console is great to learn about the service, to discover, to see what's available, how it works. But as soon as you are serious about deploying your infrastructure in any cloud provider, by the way, this is not just applying for AWS, be sure that you automate everything. So you automate the code to generate the infrastructure, but you also automate the code to create the pipeline. I forgot to show you that in the demo. Let's go back to that in just for a minute because we have a bit of time. The pipeline that I created was also created with the CDK. And the code is quite simple. It's a bit long, but it's not complicated. First, you create your reference to your GitHub. And I'm using a secret manager to store my token to access GitHub. That's the input of my pipeline. Then I define the output of my pipeline on which service and which cluster I want to deploy, and I copy-paste that from the AWS console. The rest is mostly, this is an example in TypeScript, but the rest is basically to create the different action. So I have the GitHub source action, saying, okay, that's my GitHub trigger on that repo with that owner, that token, and the output has to be placed at that place. I want to use the master branch on GitHub. Then I have my build, and it's a Docker build. I build from the source, and that's the path inside my source zip file, the build spec that I show you, on which environment. And I just give one of the many different build environments. We have Ubuntu, we have Amazon Linux, and others. Then the build action, the build action actually is this one. It's the build project with the input and the output. And then I deploy to ECS. And it's also just an object, just a construct, ECS deploy action with a service, a cluster, and I take the output from the previous step. And the last one is to put everything together. So to create a pipeline. So I create a pipeline object. And my pipeline has only 3 stages. So in order, get source, build Docker image, and deploy to ECS. And just executing that script will build my deployment environment. The runtime environment, as I mentioned already, has been created. It's the code that you saw on the slide, has been created with the CDK as well. But the idea is just to create load balanced Fargate service on a given cluster with a given image from the repository, and you give a name and the number of containers that you want to run that service, and it will create all the infrastructure for you automatically. So infrastructure as code, super important if you want to automate your deployment and if you want to automate your infrastructure. Build frequently. Do not wait weeks before trying to build the code. The more you wait, the higher is the likelihood to have an error, and fixing build error, it's a nightmare. Nobody likes to do that. In one of my previous team, we had a rule: the one that breaks the build becomes the build master until someone will break the build again. And everybody was super careful about not breaking the build. It involves checking your dependencies and be sure that you are not breaking the dependencies of your colleagues. Release in production frequently. Going to production should not be a big bang. It should not be an event in the life of your IT group. Deploying to production, it's a non-event. And the more frequent you deploy to production, the more confidence you will gain on the systems, and the more you will deploy again. It's a flywheel in terms of deployment. It means you need to do that automatically with safeguard, of course. Don't be a cowboy there or cowgirl there. So use canary release, blue-green deployment to allow you to build confidence and to not break things when you are deploying code in front of your customer. And when you collect metrics, when you collect feedback, be sure that you collect technical metric, but also business metrics. Business metrics are super important to decide on the stage of your business, and you can take technical decisions such as a rollback based on business metrics. So do not monitor only technical metrics there. So the slide will be available. There will be posts. Maybe they are already posts. You go to my Twitter account, SEBSTO. There should be posts in any minute now. And thank you for listening to me. And I will stay here for the rest of the afternoon. So happy to take any question. Happy to continue the talk also on Twitter. Do not hesitate to send your question over there. Thank you.